Okay, good afternoon, everyone. Last time we have studied work and energy and electrostatics. Now we're going to uh, understand or explore about conductors, metallic conductors, or any other material conductor in the perspective of electrostatics. Okay? Okay. Okay, so basic properties muna tayo ng conductors. And that will be this, guys. Okay? So, pag may perfect conductor tayo, ideally, theoretically, pwede tayong karoon ng perfect conductor. And ang definition nun will be, it would have infinite free charges. Itong free charges na to, nagre-reside sa surface niya. Ayan, net charges reside sa surface. Okay? So, sila yung mga nagpo-produce ng electric field. Okay? So, paano pag yung wala kang free charges? Ang tawag na dun, insulator. Okay? Wala kang free charges, magiging insulator siya. Okay, zero free charges insulator. Okay, another basic property is that, ano pala notes ko, is that yung electric field inside the conductor, yung ibig sabihin ng inside the conductor, yung sa mismong thickness ng conductor, walang electric field doon. Okay? So, kung wari, may configuration ka na may butas sa loob ng conductor, yung sa butas ng loob ng conductor na that hindi mo masasabing yung electric field doon ay zero, okay? Pero sure ka sa thickness ng conductor mo, electric field is zero, okay? Okay, so bakit naman ganun? Pwede natin isipin na yung conductor, this guy. We have a bar na conductor. So may mga charges na lumilibot sa kanya dyan. Okay? And if in-expose mo siya, ngayon sa electric field, E0, sabihin natin E0. Okay. So sabihin natin yung electric field na papass through sa kanya. To the right, to the left. So yan yung E0. Ang mangyayari sa mga charges mo, dahil conductors siya, meron siya mga free charges. Otherwise, magiging insulator siya, di ba? So, yung positive charges mo will follow the electric field, of course. So, mapupunta dito sa side na to yung mga positive charges. Then, you have your negative charges. Of course, sasalubungin niyo yung electric field. Ayan, so yan. So, magiging ganyan. And kung mapapansin nyo, magkakaroon ka ng field inside. Field inside. Na pag ganun, tama? Positive to negative tayo. And this field, let's call it E1, tends to cancel out E0. Kaya nawawalan ng field sa loob ng conductor. Okay? Okay. So outside, you can say that ano yung electric field at say this point, you can't say na it's just E0 or you can't just say na zero. Okay, hindi mo alam. Okay. Ang alam mo lang is inside, may nagka-cancel out na fields. So walang electric field inside. Okay? Tapos again, net charges resides in surface. Yung mga charges lumilibot lang sa surface. Okay. Kung i-imagine niyo in real life, itong conductor natin, ang gumagalaw yung negative, okay, yung mga electron. Kasi ang sinabi ko kasi kanina gumagalaw yung positive charges. Diba? Pero in reality, gumagalaw yung negative charges in such a way na ngayon, pupunta sila, sasalubungin nila electric field. And then dun sa other side, anong meron dun? Tinatawag tayong holes. Or ibig sabihin, just the absence of your electrons. Kaya sila nagiging positively charged. Okay? Okay. Okay. So, inside the conductor, walang charge din, virtually. Okay? Ba't ko sinabing virtually? Siyempre, yung conductor mo is made up of matter. And matter consists of protons, neutrons, electrons, etc. Diba? So, may charges doon, pero wala kang mararamdamang charge. Kaya virtually no charge inside. Kasi, kung titingnan natin yung equations natin, balik tayo sa Gauss's law. Ang differential form ng Gauss's law mo is, di ba, yung kinuha natin yung divergence. Divergence ng electric field mo must be equal to rho over epsilon naught. But again, E is 0. If E 0 sa inside ng conductor, then rho has to be 0. Okay? So epsilon natin, hindi pwede mag-0 yan. Constant yan eh. Okay? Okay. So sa conductors mo, equipotential din siya. Okay? So kung mag-measure ka dito ng potential, same lang din siya ma-measure mo sa potential dito. Okay? Kasi yung electric field mo nga is 0, then yung from any point A to B, kung yung E dot dl mo, natandaan natin itong equation na ito, then this would just be again 0. Ano implication nito? Magiging equipotential yung points at A at B. At then parehas lang yung potential din sa points na. Okay? Okay. So, and then, next one. Kung magpo-produce ng field si conductor mo, yung field mo na mapoproduce is always perpendicular to the surface. Okay? Sige, sabihin natin kuwari, meron tayong imaginary surface, imaginary conductor. Konti na. Uy, gutom na si sir. Hindi pa naman yung merienda. Kain kayo merienda, pwede kayong kumain. Ito pala yung mga joys ng online class. Pwede kang kumain anytime. Hirap kasi pag yung F to F tas nakain. Kasi basta sa harapan ka ng klase. Pagalingan kumain. Anyway. Okay. Going back, kuwari, say read yung mga charges. Di ba sabi natin yung mga charges on the surface, nandun lang sila. Kuwari ganyan. Di ko natutuloy dito. I mean, di yan negative sa akin. Dot. Okay, so tuloy-tuloy yan. Kuwari, positive charges na nagre-reside ngayon sa conductor mo. Okay. Sabi natin, electric field is always perpendicular to the surface. Why? Because immediately at the surface, hindi dito sa part na to. Okay? Immediately at the surface, perpendicular siya. Okay, why? How do we say that? So, paano yung masasabi yun? Di ba yung mga charges mo, yung electric field niya always radial. Okay? So, radial lagi yung mga charges mo, di ba? Radial yung electric field niya. And then again, kung malalagay mo siya doon, magkakaroon siya ng ganun na field. Kaso yung katabi mo ngayon, meron din field na pa ganun. Then yung katabi niya, meron na ng field na ganun. In essence, nagka-cancel lang yung mga yan. Nagka-cancel lang. So yung field mo will actually be concentrated on the perpendicular lines of the surface. Okay? So yung mga field mo pa ganun. In essence, para siya nagiging one whole charge na lang. Okay? So yung mga field lines mo. Okay? Okay. So that's your conductors. Ganun yung properties ng conductors. Now we go back to sabi ko kanina, na paano yung mga conductors with cavities. Ito, kunyari. So ito yung conductor mo, random conductor to. So yung shape niya. May mapansin mo, may charge doon sa loob, may Q. Okay? So what does that imply? Okay? Ano mangyayari sa atin? Now, suppose, by induction, okay, by induction, pag naglagay ka ng Q at this point, okay, mag-i-induce siya ng charges, hahatakin niya yung mga free charges dun sa conductor mo, such that it would cancel the field. Okay, so pag kumuha ka ng Gaussian surface, so random Gaussian surface, such that makukuha mo yung perpendicular ng things ng lahat, napansin mo that yung enclosed charge mo will be always equal to 0. Okay? Para makuha mo na the electric field inside your conductor is 0. Okay? What is the electric field in the cavity? So hindi natin alam. Unless maganda yung configuration ng conductor natin. pwede natin malaman through Gauss's law yung electric field inside here. Okay? For now, sa example na to, hindi natin malalaman yung electric field inside the cavity. Okay? So meron kang field na pa ganun, meron kang field na pa ganun din galing sa charge Q mo. So at this at any space, at any point in this cavity, mahirap malaman yung electric field there. Okay? Okay. And then, syempre, itong Q na to, in-induce niya yung mga charges, yung negative charges, for the amount of negative Q. Tama? Para mag-cancel lang yung total charge mo. And since itong negative Q mo napunta doon, dapat may counteracting na mangyayari, di ba? So, dapat dito ay plus Q. Okay? So, pag kinuha mo yung electric field ng buo, yung whole thing, outside, that would be yung field due to Q. Okay? So, kunyari, spherical to, ay di makukuha mong field outside, would be 1/4 pi epsilon naught Q over R squared. Okay? So, pag naglagay ka, in simple terms, pag naglagay ka ng charge Q sa loob ng cavity ng isang conductor, yung conductor mo will somehow imitate that charge. Wow. Diba? Okay. Amazing, no? So, ano mangyayari kapag you place an object, let's say this is a conductor, you have your weird cavity inside, and let's your conductor. Oops, no pass. Para conductor mo. Tapos may cavity ka. And then you put a neutral object inside. Kaya lagay tayo ng star. Level star. Ano na lang? Lumpia. Lumpia. May lumpia ka sa gitna na. Neutral, syempre. Neutral naman yung mga lumpia natin. Matakot ka kung hindi neutral yung lumpia. No? Kung tinapatan mo ng electric field, gumagalaw. Okay, so wari yan. And then, what happens to the electric field inside the cavity if there's no charge inside? Honey, anong mangyayari? Anong field inside the cavity kung wala namang charge? Anong mangyayari dun sa field inside the cavity kung wala naman siyang charge particle inside?
Wala lang din po.
Okay, wala lang din. Tama, tama. Very good, very good. So, yung anong mangyayari dito, walang field lang. Dahil dito, ang mangyayari, tama si Honey, no? Mangyayari ay yung field inside the conductor, sa thickness ng conductor, 0. Then, dapat yung electric field din, here inside the cavity is 0. Okay. So, kahit i-bombard mo siya ng electric field outside ng conductor, walang mangyayari. 0 pa rin yun. Kasi, kuwari, sige, sabihin natin, binombard natin siya ng electric field E1. Okay, ano mangyayari sa mga positive charges mo? Mapupunta this side. Blue natin siya. Oops, then sa packing load. Okay? And then, dahil dito may induce kang charges sa loob na negative. Tapos ito may induce yung charges dito inside. Plus, plus, plus. Then at this point, negative, negative, negative. In essence, magka-cancel lang yung field outside, inside here. Okay? So wala talaga siya mararamdaman ng electric field. Amazingly. So, napansin niyo ni Michael Faraday. Hindi siya makapaniwala eh. So, tinry niya. Let's read this. So, ito yung Faraday cage from the Experimental Researches in Electricity, Volume 1, in 1849. So, ito, let's read. Ay, ano nangyari? Ay, wait lang pala. Hindi ko pala na-set as... Okay, so basahin natin ito. Yan. So I carried these experiments on with air. Ang weird no, ano, tingnan nyo, pansinin nyo yung grammar nila. Ito ay way back before, so 1849. And this is uh, in the UK, in the joke, charot. Nasaan yung London? Basta nandun sa mga British people, mga English people, diba? So weird pa yung ano nila, very weird pa yung grammar nila compared sa modern grammar natin nila. Okay, so I carried these experiments on with air to a very great extent. Okay. I had a chamber built being a cube of 12 feet. A slight cubical wooden frame was constructed and copper wire was passed along and across it in various directions. So binalot niya yung cube niya with copper para daw siya makagawa ng so as to make the sides a large network. And then all was covered in with paper, bali insides binalutan niya ng papel, placed in close connection with the wires, and supplied in every direction with bands of tinfoil that the whole might be brought into good metallic communication and rendered a free conductor in every part. So, ang point lang is gumawa siya ng chamber na gawa sa bakal. Okay? So, this chamber was insulated in the room, in the lecture room. Outside nung cube mo, insulated siya with everything. Okay? So, sa Royal Institution, and then a glass tube about 6 feet in length was passed through its side, leaving about 4 feet within and 2 feet on the outside. Through this, a wire passed from the large electrical machine to the air within. So may connection yung loob. Tapos, tinitignan niya ngayon kung yung air magiging charged inside. Okay? Bali, iilaw yung air. Okay? Kasi pag ionize mo yung air, diba? Iilaw siya. Parang bombilya lang. Nilagyan mo ng kuryente, maghihiwalay yung mga electrons mo, ilaw sila. Okay, so by working the machine, the air in this chamber could be brought into what is considered a highly electrified state. Okay, so yun yung point niya. Gusto niya kuryente yung air inside. And at the same time, the outside of the insulated cube was everywhere strongly charged. But putting the chamber in communication with the perfect discharging train described in a former series, and working the machine so as to bring the air within to its utmost degree of charge if I quickly cut off the connection with the machine. And at the same moment, okay, or instantly after insulated the cube, the air within had not the least power to communicate a further charge to it. So, ang ginawa niya is kinoriente niya yung cube. Then, dinisconnect niya tapos syempre may mga charges pa din. Then, titignan niya ngayon kung ilaw yung air sa loob. Ano nangyari? Wala siya nga pala. If any portion of the air was electrified, as glass or other insulators may be charged, it was accompanied by corresponding opposite action within the cube, the whole effect being merely a case of induction. Okay, so ganun niya mini-measure yung mga bagay-bagay. Tinitingnan niya kung may induction. Kasi dapat kung naging charge yung air, magkakaroon ng induction. Tama? So yeah, every attempt to charge air bodily and independently with the least portion of either electricity failed. Okay, so hindi siya satisfied dito, no, na charge niya. Baka may mali siya. Sabi ni Faraday, baka may mali lang ako. Sige, ulitin natin. Yan. So naglagay siya ngayon ng, I put a delicate gold leaf electrometer within the cube. So ang gold natin kasi is a very good conductor. Mataas yung marami siyang free charges. And then charge the whole by an outside communication very strongly for some time together. But neither during the charge or after the discharge did the electrometer or air within show the least signs of electricity. So tinry niya, no? Baka mali lang yung pang-measure niya. So tinry niya yung gold leaf na electrometer and then nangyari, wala pa rin talaga. So, and then, frustrated na siya, I charged and discharged the whole arrangement in various ways, but in no case could I obtain the least indication of an absolute charge, or of one by induction in which the electricity of one kind had the smallest superiority in quantity over the other. Ito na. So, medyo sira ulo si Faraday. I went into the cube and lived in it. And using lighted candles, electrometers, and all other tests of electrical states, I could not find the least influence upon them. or indication of anything particular given by them, though all the time the outside of the cube was powerfully charged, and large sparks and brushes were darting off from every part of its outer surface. So the conclusion I have come to is that non-conductors as well as conductors have never yet had an absolute independent charge of one electricity communicated to them, and that to all appearance such a state of matter is impossible. So dito niya na discover yung Faraday cage na tinatawag natin. Okay. So ang ginawa niya, 'di ba, namuhay nga siya sa loob ng cube. And then yung assistant niya, halos mamatay-matay na sa labas kasi talagang kinukuryente nila yung tube. Tapos wala naman daw nararamdaman si Faraday. Okay. So yan, amazing. Okay, so kung mababasa nyo, kung nagbasa kayo sa Griffiths, no? Kung nagbasa na kayo na tong part na to, may comment si Faraday, ay si Griffiths sa Faraday cage. So sabi niya, basahin ko na lang. Sabi niya, this is why you are relatively safe inside a metal car during a thunderstorm. Okay? You may get cooked, maluto, if lightning strikes, but you will not be electrocuted. Okay? So yung kotse para siyang Faraday cage na sa thunderstorm, relatively safe siya dahil hindi ka nga makukuryente. Okay? Ang problema lang, baka maluto ka sa loob kung tatamaan ka yung kidlat. So, hindi mo maiiwasan yung heat. Okay? So, ayan. So, that's how powerful your Faraday cage. And matatry nyo rin to sa mga cellphone nyo. Pwede nyo lagay sa loob ng ref yung cellphone nyo, sa lagay ng freezer. Dahil yung sides ng freezer, para siyang electrical conductor na cube, conductor na quadrilateral. Okay? So, ang mangyayari doon, dahil yung mga radio frequencies mo, well, electromagnetic waves in general are electromagnetic waves. So, electro, meaning electric. Ang mangyayari sa mga electromagnetic waves mo, hindi siya papasok sa loob ng Faraday cage. Dahil E is equal to 0 inside the conductor. Bakit hindi naman po nasunog si Faraday? Okay, ba't nga ba malay ko sa loko-lokong yun? Hindi yata enough para masunog yung ginawa ng cube. Dahil masyado malaki. 12 feet by 12 feet. Okay. So, para siyang apartment, maliit na room. Ang nangyari kay Faraday, dahil sobrang obsessed ni Faraday sa, well, hindi na-obsessed, mahilig lang siya mag-experiment with electricity and magnetism. Ang nangyari sa kanya is naging ulyanin siya. I don't know, baka may connection yung pagiging kinukuryente niya lagi sarili niya sa pagiging ulyanin. Okay. So, yan. Enough story. Balik tayo sa kung anong important sa buhay natin. Siyempre, pag mag-exam tayo, paano na ito ginagawa, diba? Okay, balik tayo. Sir, dali ng example na binibigay mo. So, again, gawa tayo ng problem. Sagutan natin yung problem. Okay. So, yan. Problem 2.38. What do we need? Draw ko muna yung problem, no? So, a metal sphere of radius r is surrounded by a thick concentric metal shell. So, may shell daw sa labas na conductor. Yes. Yan. Sorry guys, pangit yung drawing ko. Mahirap mag-drawing sa tablet na mumurahin. Okay, so yan daw. Pag may pera na tayo, bili tayong iPad para madalagutan. Anyway, ito ay lagyan natin ng markers. Ito ay R. Ito ay A. Then outer radius B. Okay? So, kuwari ano to, imagine niyo na lang maganda drawing ko. Metal sphere, radius R. Tapos may metal shell ka sa labas. Okay. So, unang tanong, find the surface density, charge density, sigma at R, A, and B. Okay, let's do that. A. So, meron tayong tatlo. Ang general form ng sigma natin will be Q. The total charge must be equal to the sigma, the charge density times the area. Tama. Okay, so sigma has to be, sigma, may tatlo tayong tinatanong, sigma R has to be Q over A, area ng R, then Q, sigma A, Q over A, sigma B, Q over A, B. Okay? Clear naman yun, di ba? And then the surface area for these guys is easy. That is 4 pi R squared. Tama? Papalitan mo na ngayon si R kung ano yung mga values ng mga tinatanong. So sa R, magiging Q over 4 pi R squared. Tama? Q over 4 pi A squared. And lastly, Q is just 4 pi B squared. Okay, dali lang. Dali pa yan. Find the potential at the center using infinity as a reference point. Okay? Kailangan natin ngayon mahanap yung electric field. Then, madali na lang to, di ba? Kasi pwede na tayo gumamit ng Gauss's law. Dahil spherical naman yung problem natin. Kailangan lang natin malaman kung saan magagaling yung charge. Okay, so inside, that will be Q, itong sphere mo, Q, tapos uncharged daw yung itong malaking shell mo. Okay? So in general, you can just write E has to be, I can get the whole thing. I can get the area for your Gauss's law to enclose everything. Kasi yung total charge mo lang naman is Q enclosed. And pag nilakihan mo yung surface mo, makukuha mo lang yung total charge Q. So E has to be Q enclosed, Q enclosed over epsilon naught times yung A area. And I could write this as yung total na Q. Kasi kung lalakihan ko lang yung area ko, to accommodate everything squared. Okay? Okay. Then I have E. Pwede kong gamitin ngayon si definition ng V as sabi, or nagkumura tayo ng V, gamitin out natin yung infinity as a reference point. So V has to be negative infinity to some point to 0. Kasi ang tinatanong niya, potential at the center. Okay? E.E.L. Now, EMO is just directed towards the radial component. So, yung DL mo magiging DR lang. Okay? And then, hihiwalayin natin itong integral natin into 4 different things. So, let's start with from negative infinity towards the outer shell, B. Okay? So, what is the field there? It's easy. 1 over 4 pi epsilon naught Q over R squared dr. Tama? Easy. Then, dadagdag ko yung integral from infinity, joke. Tutuloy natin to B. Then, sa A. Okay? And then, we know sa region na to, ito yung spherical shell mo na conductor. And then again, yung electric field inside the conductor is 0. So we have that. Add natin yung A to R by Gauss's law. Makukuha mo lang din to. 1 over 4 pi epsilon naught Q over R squared ER. Lastly, that will be R to the center of your spherical conductor. And then again, nasa loob ka ng conductor, so 0. Okay? Okay. And then we evaluate. This is 1 over 4 pi epsilon naught. Epsilon naught. Q over R. Tama? Q over R evaluated at infinity to be this is 0. Then I'll add this. Magiging plus siya dahil pag integrate mo 1 over 4 pi epsilon naught Q over R evaluated from A to R. Then this is 0 again. Okay. And then we have simply 1 over 4 pi epsilon naught. Evaluate this at B. So that is Q over B. Okay. And then minus, evaluate to this point. So 0 lang yan, di ba? Tama. Q over infinity is just 0. And then I'll continue with my life here. So unahin ko si Q over capital R. Tama. Minus Q over A. Very straightforward. Okay. So ayan yung potential mo. That is using the reference point as the infinity, then towards the center. Okay. Now, letter C. Now the outer surface is touched to a grounding wire, which drains off the charge and lowers its potential to 0. Okay. So pag may grounding ka na nagaganap, hahatakin na ngayon yung mga free charges mo at that surface. So what happens? So how do your answers to A and B change? Sa A natin, ang mangyayari, so lagay na lang muna natin dito yung sagot natin para madaling i-pattern. Sa A mo, ang magbabago lang will be sigma B. Sigma B will be 0. Okay? Dahil hinigop nga ni ground yung charges mo. Sir, bakit hindi kasama yung sigma A? Kasi sa sigma A, continuously nagkakaroon ng charges dito. Dahil ina-attract siya nung sphere mo sa loob. Okay, sir, question po about sa E field from A to B. Hindi po ba kasama yung Q enclosed yung charge po ng sphere? Paano po ulit nag-zero yung field? Saan yun? Dito ba? Dito sa point na to. Let me chat it para alam ko. Okay, so dito dahil itong part na to, itong B to A, yung B to A mo is within this guy. Okay? So again, the basic properties ng conductor mo, E is 0 inside the conductor. Okay? So regardless no kahit gano'ng kalakas yung mga karami siyang katabing charge, may gagawin siyang field inside such that it would cancel out kung ano nararamdaman mo. Wow, good. Okay? Itong dalawang to, nag-zero out sila kasi these are the regions inside the conductor. So, ayun yung sense ng conductor. Zero out. Compare mo yan dun sa unang parts natin na meron kang charged object. na distributed evenly yung charge niya dun sa all over its volume. So magkaiba yung sagot nila. Okay? So medyo nakakalito, no? Kuwari may spherical ano ka. Kuwari yung magkaiba yung field ng ano, di ba? E-field ng spherical conductor. Conductor is not equal to the E-field of spherical charge. Okay. Ito linear yung field sa loob, di ba? Kung naaalala nyo. Yung ginraft nyo na ganun, naalala nyo ganun. Okay, okay. Tapos ito, zero inside. Kasi conductor na siya. Okay, continuing. So ayan, nag-zero yung sigma mo dun sa kung saan nakatouch yung ground. Okay? Then lastly, ano mangyayari sa potential mo? Ang mangyayari is that yung B to infinity, wala ng charge, wala ng field. Tama? Okay. So magiging V is equal to negative infinity to A na siya. Na zero. Zero lang din. Nagdikit ko na, no? Kasi dahil sa kuwari, dahil yung negative infinity to B, zero na din. Tapos yung B to A, zero din. Then pwede mo silang i-combine like this. Okay. So you have this. And then you just continue with your life. Meron kang A to R, then R to 0. Okay? Pero yung R to 0, alam naman natin, 0 lang. So we are actually left with negative from A to R, 1 over 4 pi epsilon naught times Q over R squared dr. Ito lang din yan, kinopya ko lang. This guy. Okay? And then you'll have your answer as 1 over 4 pi. This is 1 over 4 pi epsilon naught. Tapos Q over capital R minus Q over A. Okay? So that's it. May tanong ba? May tanong? Okay. Kung wala, meron, chat nyo lang or salita kayo. Okay? Now, let's look at the things. Paano yung force on a surface charge kapag may conductor ka. Kuwari may conductor kang ganyan. Tapos mga charges ka nakakalat mo sa conductor mo, di ba? Sir, wait po. Yakit ko ba? Sorry. Pinakopya niyo ba? Ay, sorry po. Dito. Yan. So, magiging ganun na. R minus A. Okay na ba? Let's continue. Okay na, sir. Okay. Okay, tingnan natin ngayon kung ano mangyayari din sa mga charges mo sa surface kapag tinapatan mo siya ng electric field. Okay? Kung ano mararamdaman na ba nilang pwersa. Okay, so kung maaalala nyo, kung maaalala nyo yung lesson dati, buklatin na lang natin. Kung maaalala nyo to, E above at E below, may discontinuity sila na sigma over epsilon naught. Okay, so through a conductor, wala may conductor ka, syempre yung pag pumunta kang pa ganun, ang discontinuity niya agad is this guy. Kasi zero inside. Tapos magkakatalon siya ng discontinuity. Magkakaroon siya ng sigma over epsilon. So E above, diba? Minus E below is just sigma over epsilon naught. And hat. And since yung E below mo, for a conductor, zero lang. Kasi yung E below is E inside, tama? So you have this guy. And the corresponding potential can be written as this. So partial V, partial N, partial N, just, this is from the last lesson. In lesson 5. Okay? So ayan. Okay. Anong point natin dito? Ang point natin dito is gusto natin alamin yung force per area. Ito ay force per area, kaya small. F is force per area. Okay? Pag F yung legit na force. Okay, so ito. Ang tanong natin, di ba kung naalala nyo, ang force can be written as Q, then the field. Okay? If it is a force per area, then we have A divided by A. Q over A is just your charge density. So if we lumipat tayo, magiging sigma. Kung surface charge yung pino-point out natin, then we have that. Okay? Okay. However, we have a problem with E. Anong gagamitin natin na E? Kung meron tayong arbitrary surface. Arbitrary surface. Oops, ang pangit ang drawing mo, sir. Arbitrary surface. Lalagyan ko ng ganito. Ibig sabihin ito ay conductor. So, E is 0 here. E is 0 here. Okay, conductor kasi ito. Anong kukunin natin na electric field if tinapatan natin siya ng, say, meron kang field outside. Diba? Kung meron kang field na outside, syempre, meron kang something na E above, meron kang E above, at meron kang E below. Okay? So, anong kukunin natin dito sa dalawang to? If there is a field outside. Then, the answer would be the average. Okay? So, bakit ba average? Parang scammers yun. Okay? So, kuha tayo ng patch lang. Kuha tayo ng green na lang. So, green. Kuha tayo ng patch. Small area patch. And then, there will be the electric field there will be, of course, the patch that pinoproduce ng patch kasi charged surface to, di ba? Ito ay charged surface plus E others. Your E outside. Sige, E outside. Tawagin na lang natin E others na parang hindi nakakalito kasi may inside, outside, may out, below, above, others. Okay? Now, yung force na mararamdaman nito, of course, will exclude the patch. Okay? Bakit? Isipin nyo na lang binubuhat yung sarili niyo. Hindi pwede yun, di ba? So, hindi niya pwedeng i-exert yung force sa sarili niya. So, we have to disregard this guy. Okay? So, yung force will just be due to to others. Tama? Okay? Okay. Let's see the field above. Yung above the patch, ang makukuha mong field is of course the discontinuity, sigma over 2 epsilon naught. Sigma over 2 epsilon naught. Let's check in. Okay, so yung discontinuity yung makukuha. Okay? Which is this, and then plus yung E others. Okay? And then sa above, below, below. Ito ay n hat. Okay? Sa below mo, dahil nakatutok pababa yung mga field dyan, dahil sa surface, and then makapansin natin na negative ito. Okay? N hat. Dahil yung E below mo is pataas, kasi yung field sa part na yan ay below, then negative. Plus again, E others, dahil outside naman ito. Okay? So idadagdag ko pa rin tong mga things, yung mga things na ito. Okay? And then so, mapapansin mo, nababalik tayo dun sa equation na to pag inad natin itong dalawa. Okay? Wait. So para makuha natin yung E others, i-add lang natin sila. So this is E above plus E below. Okay? And this is just 2 E others. Okay, and then E others, all the things just will be EA plus EB. Pagod na ako magsulat, guys. Hindi nyo na lang. Okay, yan. So, average lang siya ng above at below. Okay, bakit natin kinuha yung E others? Kasi, this guy. Okay? Make sense? Make sense? Okay. Okay? Kuha. Kuha. And then the force, again, will be F is sigma plus 1/2 yung average ng E average. And then for conductors, yung average nung above and below would be sigma over check ko lang. Will be sigma over epsilon naught outside, tama? Plus 0 inside. Kuha yun. So tanggalin ko muna ito yung, tanggalin ko muna. Sir, bakit po ulit nag-0 yung e-patch? Bakit nag-0 yung e-patch? Dahil yung sa patch na ito, ang mararamdaman niya lang forces will be the external fields, yung E others or E outside. Okay? Hindi niya mararamdaman yung force due to itself. Okay. Kuwari, ngayon nga, tumayo kayo sa basket, ang makaka-apekto lang sa inyo na force is yung mga tutulak sa inyo, yung gravity, etc. But you can't exert a force na bubuhatin niyo yung basket tapos aangat kayo. Okay? Gets ba? So yung E field coming from this patch can't exert force on itself. Ayan. So yung E from this guy can exert force on itself. So yung mga others lang yung makakapag-exert ng force sa kanila. And then yung others na yun, kinumpute natin as this guy. Okay? Sir, bakit, kala ko ba wala yung patch, sir? Ba't may ganito, sir? Okay. So, ayun, pwede question yun, no? Bakit may sigma over to epsilon naught, no? Kasi, again, lahat ng fields mo dadaan through that process na magkakaroon sila ng discontinuity. And that discontinuity is just the half of sigma epsilon. So, E others, pag tumawid siya sa surface na yun, dagdagan siya. Pag tumawid siya pababa, mababawasan siya. Okay? So, hindi ito sa patch. Ito yung sa pagtawid ng mga others na electric field. And then, pagkakuha natin E others, pansin natin, average lang siya nung above at below. Okay, so yung above for a conductor is sigma over epsilon naught. And then below, or the meat, or the thickness of the conductor is 0. Yung field doon is 0. So you have sigma squared over 2 epsilon naught. Okay? Okay? So this is your force per unit area. Okay? Okay. So yung direction yan will be in hat, of course. Gawin natin vector. Okay, we can rewrite this as yung physical quantity na lang na measurement natin. Di ba alam natin yung force per area is this guy, and this is also pressure. Di ba? Pressure then will be equal to, if you don't know, pwede natin select to as this guy, epsilon naught, or we can simply write that E sigma over epsilon naught, then E squared is sigma squared epsilon squared. Okay? So plugging that thing in, so epsilon naught over 2 E squared. Okay. So yung pressure na mararamdaman ng charges sa conductors mo kapag tinutukan mo na electric field will be this guy, this much. Epsilon over 2, epsilon naught over 2 times yung E squared. Okay? Di na ba yan? Nice, no? Okay. So that's it. Now, let's consider two conductors. Meron kang conductor A, conductor B. So, mga conductors. Not necessarily spherical, no? But some random conductor. Okay? So, we have capacitors. And then, if I put a charge, if I put a charge Q here, then Q minus here, tapos tignan ko ngayon yung potential nila. So, i-define ko yung potential ko as yung V, potential difference as V plus, V minus. So, yung V plus manggagaling sa plus, and then V minus manggagaling sa this guy. Okay, so, again, V can be written as V started with DL. Okay? Okay, so walang bagong thing dito. So, kuwari, may dalawang conductor, tapos may charge, excess charge sila na Q at Q minus. Yung potential difference between those two conductors will just be this guy. Okay? Okay, klaro. And then, kung mapapansin mo, si E, naalala niyo pa ba yung weird na form ng E? Or yung hardcore form niya? This is actually equal to integral niya r squared r hat rho d tau. Di ba yun yung mahirap na form ng electric field? Tama? Okay? So si E, directly proportional siya kay rho. Pansin niyo yan? Inversely proportional sa R, Wala pang something bago. Ang bagal ko. Okay. So, pag dinoble kasi 2 times ng row, magiging, ano yan, proportional siya sa 2 times na electric field. Okay, klaro ba yan? So, si rho, or yung charge distribution mo, is actually proportional to E. Then, kung papansin nyo dito, proportional si E kay V. Then, we could actually write V as something like baliktad. Mas maganda yung baliktad. Mapapansin natin na si rho, or yung charge mo, Q na lang, total charge. Kasi pag dinoble mo yung total charge, dodoble din naman yung per unit niya or yung density niya. Okay, so ayun ay proportional kay E and proportional to V. Okay? Napansin nyo dito, V is proportional to E. So Q is actually proportional to V. Okay? And then we will construct a constant of proportionality to accommodate for everything that's left out. We have Q will be defined as C times V. Okay, dahil si Q ay proportional kay V, Q ay proportional kay V, gagawa ko ng something na constant C. Okay? Para malaman ko yung relationship nilang dalawa. So C yung variable na mag-hold ng mga anything else. Okay? So si C, tinatawag natin siyang capacitance, capacitor yung object. And then C is measured in farads, named after Faraday, of course. And then this C depends only on the geometrical properties of the system. That is, yung size, shape, and separation of the conductors. Okay. Okay. So, gawin natin to. Example. Siyempre, parang hirap naman yun, sir, para wala tayong example. Okay. So, may parallel plate capacitor consisting of 2 metal surfaces of area A held a distance D apart. Okay? Okay. So, we have, itatayo ko lang muna to, no? Tayo ko sila. So, I have this guy. Okay. Then, suppose, baliktarin ko naman yung system, no? Okay lang, ano ko na dito yung plus Q minus. Okay? So, kuwari, meron tayong dalawang plate, 2 metal surfaces, then meron silang charges Q and Q minus. Okay, so what is the capacitance of this system? Tapos ito ay separated with distance D. Okay? Okay. So, paano ba ito i-solve? This is easy. Gagamitin ko yung mga boundary conditions ko. Dahil ito ay surface, then I can just write this is just, meron siyang field na pala ito dahil positive siya. Then this guy has a field inward. Inward na ganun. And the strength of this guy is sigma over 2 epsilon. The strength of this guy is sigma over 2 epsilon. Strength of this guy is sigma epsilon. Ginagamit ko lang yung boundary conditions ko. Ganyan, di ba? Okay? Now, tignan ko ngayon sino magkakasamang direction. Ito. Inside this configuration, magka-direction itong dalawang to. So the field is actually going to the right from Q to Q minus. And then that would be 2 epsilon naught plus sigma over 2 epsilon naught. Now, sigma is the same kasi same na area lang sila. Okay? And I have sigma over epsilon naught. Okay? Now, walang given na sigma sa akin. So, I have to say na yung eco will be the total charge Q epsilon naught over A. Kasi si sigma is just the total charge divided by the area. So this is the field between those two parallel plates. Then I need to get the potential to get the capacitance, di ba? Q is equal to CV. Gawin ko to. Okay? Okay? So I have my potential, negative D to 0. Tama? Kasi from negative to positive ako. And then I have your E, your TL. And we know yung actually yung E mo di nagde-depend sa distance ng dalawa. So, this is constant, di ba? Hindi naman nagbabago yung A pag pinaglayo mo sila. Hindi naman magbabago yung charge kung paglalayoin mo sila, paglalapitin mo sila. But it doesn't matter. Everything goes out. And I have Q over epsilon naught A times 0 to D. Pinasok ko na yung negative sign sa loob ng integral. Then this gives me simply D. QD over sigma. Epsilon naught over D. Okay? Sorry. That is your potential. QD over A epsilon naught. But what we need to find is C. C is equal to Q over V. So I have this. Q over V. And this is simply cancel out, epsilon naught A over D. Okay? Okay, so the bigger the plates are, the larger the capacitance. The farther the plates are, the lower the capacitance. So again, nagde-depend lang siya sa geometry ng system niya. Amazing, di ba? Okay, next, find the capacitance between two concentric spherical metal shells with radii A and B. Okay. I'll place my, so drawing muna tayo ng problem natin. Ayaw na nag-mura. So drawing muna natin. Okay, two concentric spherical metal shells. Okay. Metal shell pa lang. So, you have that. What is spherical yan? Then you have two radii, A, B. Okay, so store ko ngayon si Q plus inside. Q plus, then this is Q minus. Okay. Si Jello, are you there, Jello?
Yes po, sir.
Anong field outside?
Hello? Sorry. 0 po.
Okay, very good. Bakit zero?
Kasi magka-cancel out po or bali magiging 0 po yung Q and close.
Very good. Galing. So maraming mga problems na mapapadali pag inisip nyo through Gauss's law. No? Okay? So kung inisip nyo, gagawa kayo muna ng integral, wala. Mamali na kayo. So very good, no? Q and close mo, kapag gumawa ka ng malaking Gaussian surface outside, magiging Q plus Q minus. And same magnitude yung mga Q mo. So zero lang yung electric field outside. Okay, may tanong, sorry. Sir, question po sa 2.11, paano po naging sigma over 2 epsilon naught yung P? Paano naging sigma? Ito ba yung tanong mo, sorry? Yes, sir. Okay, balik tayo sa surface na rectangular surface. Then Gaussian, gawa tayong Gaussian surface na box. Yung pill box mo. Okay, so magpapass through yan. Yan. And then yung area mo is A. So may sigma ka. And then kung kukunin mo yung field here will be 2A. Tapos total charge enclosed will be sigma A over epsilon naught. Ito ay Gauss's law lang. And then you have sigma over 2 epsilon naught. Kuha? Kuha, sir. Okay. So double check natin no para parang ano naman tayo, parang scam naman tayo. Gagana ba yung boundary condition pag tumawid ako? Pag tumawid ako pa ganyan, meron akong masasalubong na field na sigma over 2 epsilon naught. Then yung discontinuity ko will be sigma plus epsilon. So pag tumatawid ako ng charge, surface charge, madadagdagan ako ng sigma over epsilon. And this guy is sigma over 2 epsilon, which is yung field na ito. Okay. So very useful yung boundary conditions to check things. Okay? So makes sense, di ba? Okay, so going back, si Elijah, are you there, Elijah?
Hello, sir.
Ano yung field inside here?
Sa inside po, yung
Ano, sorry? I didn't hear, sorry. So inside, anong field inside?
yung pinaka-inside po, yung
Less than 8, bali.
zero din daw, sabi
Ah.
naman.
Okay, 0 din. Bakit? Ang tanong ay spherical metal shells. Bali, conductor ito. 0 dahil, Elijah.
Zero din po yung enclosed.
Okay, bakit? Kasi walang charge enclosed inside. Okay? Kuha ba yan? Okay. So yung field lang natin nandito lang sa region na to. Okay? So yung integral natin doon na lang natin hugutin. So V will be negative from minus, the Q minus part will be B to A. Tama? And then that will simply be 1 over 4 pi epsilon naught. And then your Q over R squared. dr. Diba? And this will be Q over 1 over 4 pi epsilon. Yes. For epsilon naught. 1 over R evaluated from B to A. Okay? And this is Q over 4 pi epsilon naught. 1 over A minus 1 over B. Tama? So yung capacitance mo will be C. Okay, so double check lang, no? Kailangan kasi yung ano mo, yung potential mo positive kasi positive quantity si capacitance. So positive to, tama ba? Mas maliit si A kaysa kay B. So mas malaking number to kasi sa number nito. So makes sense. Wala lang, ano lang. So ito ay Q over V, then we have Q over Q for pi epsilon naught. Tapos 1 over A minus 1 over B. And this guy cancels out. Matagilid ng sulat ko. 1 over 4 pi epsilon naught. And then parang hindi ka nahirapan, pagsamahin natin sila. B minus A times B. So we have 4 pi epsilon naught. 4 pi epsilon naught AB or over B minus A. Charan. That's it. AB, B minus A. So, that's it, no? Ay, hindi pa pala. Charot lang. Okay, paano naman natin, di ba, alam naman natin na yung mga capacitors natin, they have energy. Di ba? Kung naalala niyo yung mga experiment ko dati, nag-i-store ito ng energy. Okay? So, you have two plates. Let's say I assume two plates. Then, you have to charge things up. Dito zero charges pa lang din. Dito is Q. You want to switch things. Kung dadalhin mo yung Q doon sa papuntang kabilang plate, ano yung energy na required para doon? And so you have W will be Q V. Okay? So at any point, dW, yung Q ko, yung V ko pwede kong isulat as yung V ko, di ba, ito ay Q is equal to CV. So V can be written as Q over C. Okay? Okay? Q kuha yan. Sir, bakit? Itong Q na to yung ginagalaw mong charge. Tapos yung V na to, yung nararamdaman ng charge na yun. Okay? So kung wala ka pang nalilipat, this becomes at T is equal to 0, this is just dW equal to dQ Q0 over C. So yung mararamdaman nitong field, wala. Tama? And then at the end of the time, nung na-charge mo na, dQ, yung nalipat mo na na-charge. Okay? Okay? So in mathematics form, yung total work done will be the sum ng paglilipat mong yun. So I0 to capital Q ng Q over C tapos dQ. Okay? Okay. Diba? Make sense to, diba? Kasi pag nasa 0 tayo, ito yung mangyayari. Nasa Q tayo, ito yung mangyayari. So in general, ganito yung tsura niya. Then if you are gonna do the integration, you will have 1/2 Q squared over C. Then you plug in, evaluate Q, 0. You're left with 1 over 2 Q squared, capital Q squared, yung total charge na, over the capacitance C. And if, again, you can write Q is equal to CV, so Q squared is just 1/2 C squared V squared C. And you're left with 1/2 C V squared, which is yung alam yung energy ng capacitor. Okay? So, that's it. That's it for chapter 2. Hanggang dito na lang yung chapter 2. Next meeting, chapter 3 na tayo. And yung chapter 3, mag-dwell yan sa potentials. Yung mga techniques pa natin para makasolve ng potential. Okay. So we're not done yet. We're done with chapter 2, but we're not done. So we have that. May questions ba from the lessons today? Mag-check ba? Okay, mag-check. Wait lang. Okay, so may mga tanong tayo. Sir, may capacitance ba po ba kung like charges yung dalawang surface? Wala. Bakit? Kasi yung potential mo zero. Diba? Wala kang potential difference. Okay, so unang tanong, may capacitance ba kung like charges? Wala. Dahil wala kang potential difference. Sir, sa problem 2.38, nakakalito po i-determine charge sa bawat bound po. Pwede po pa-explain fully kung bakit zero yung 2 sa 2 bounds. Okay, we're gonna go with that. Share screen ko lang ulit yung problem natin. Okay, kita na ba? Kita na? Problem 2.38. Okay. So, saan nalito? Sa... Baka hindi ko naintindihan ito. Sir, nakalito po i-determine yung charge sa bawat bound. Ito ba yung tinatanong mo kung bakit nag-zero out siya? Chat ka kung ito. Okay. So, para makuha natin yung potential, which is this guy, equal yun sa electric, integral na line integral na electric field mo. Ngayon, bakit ako dumaan dito sa way na ito? Bakit ako dumaan sa way na to? Kasi madali ko makukuha yung electric field ko, which is through Gauss's law. Okay? Kasi mga spherical objects yung tinatakan natin. Okay? And then, as I do this integral, negative infinity to 0, magkakaroon ako ng different bounds. Okay? Infinity to b, b to a to r, then r to 0. Okay? So, ang gusto natin makuha yung ito. Sa center daw yung potential, then yung reference point po, infinity. Ang yung tanong. Okay? Okay, so klaro pa naman doon. Nagkaroon tayo ng 4 integrals dahil may sa object sa tanong natin, merong 4 boundaries. Yung infinity to this point, then putulin mo sa loob naman, then to this point, then to this point. Okay? And then, yung loob mo, this is as metal sphere. Conductor ito, then conductor din yung shell mo. Yung shell mo may thickness, no? Kasi from A to B yung radius mo. Okay? Okay. So now, going back. Okay. Going back, pinutol natin yung mga regions natin. This. Kasi nagbabago yung mga fields at those points. So this guy, this is from Gauss's law dahil yung closed enclosed charge mo lang will be Q. Kasi uncharged yung shell mo, pero yung metal sphere mo sa loob is charged by Q. So kapag gumawa ka ng malaking Gaussian surface, then you have this electric field. Now, from B to A, ito ay yung shell mo. Okay? So inside that conductor, kahit anong mangyari, the electric field is always zero. So we plug in E is equal to 0 there. We have that. Okay. So sa A to R naman, same quantity nangyayari. Pag kinlose mo yung region na yan ng Gaussian surface mo, total charge pa rin is Q. And then the corresponding field is like this. Okay? Then to R to 0, kaya siya ng 0 dahil this is a metal sphere, not a spherical shell. Okay? So metal sphere, yung loob nun, conductor pa rin. So mag-zero out yung electric field doon. Okay? Okay? So let's continue at this point. So bakit nag-zero out na yung B to infinity? Yung B to infinity, nag-zero out na rin siya. Kasi ngayon, wala na siyang minimimic na charges. Di ba ito ay, kunyari, isipin yun, meron siyang blue green na lang. Meron siyang charges na Q. Okay? Yung charges na Q. Okay? And maghahatak ngayon tong metal sphere mo ng negative sa inner side ng shell mo. Okay? Tapos sa outside shell mo, may positive. To compensate dun sa mga nahatak. Okay? Now, in the first problem, pag gumawa ka ng Gaussian surface outside, the enclosed charge will be Q minus Q plus Q. Okay? Q minus Q plus Q, that is Q. Kaya nakukuha mong electric field at this part is the usual thing. However, kapag nilagyan mo ng grounding, kapag ginround mo na to, yung mga charges na yan nawawala. So, yung integral from infinity to B, yung potential dyan, yung electric field mo ngayon will be, of course, the enclosed charge. However, ang i-add mo na lang will be this guy, minus Q plus Q. Minus Q plus Q all over 4 pi epsilon naught r squared. And this is just 0. Okay? Because then again, yung B to A, yung B to A is just the meat, yung karne ng conductor mo. So 0 lang din yung electric field. Okay? Kahit anong mangyari, 0 yan. Okay? So nag-0. Kaya pinagdikit ko na lang dito sa part na to. Infinity to A na siya. Okay? Nalinawan ba? Nalinawan ba? Chat naman. Okay. Okay, what a nice. Okay, so di pa tayo tapos dahil stop recording ko na para okay na tayo.